Greetings again, everyone. Welcome back to my channel, Professor underscore 101. If you have not yet liked, shared, or subscribed to my channel, please feel free to do so at any given time. Okay, so in today's lesson, I'll be talking about algebra. And in the branch of algebra, I'll be discussing simultaneous equations. Now, what are simultaneous equations? Simultaneous equations is when you're pairing more than one equations together to solve more than one variables. So let us take a look at that. So in explaining that, which I just explained to you, is that we're going to have two pair of equations. So we're going to have a plus b. We're going to set that to equal to 7. We're also going to have a minus b. That's going to equal to 3. Now, if we were only to use one of these equations, if I was just to take out this equation right here, I cannot solve a or b. But if I have more than one equation where A and B are in, I can actually solve my equations. Now let us take a look at that. Now, for now we're just gonna use some random numbers just to explain this. If A is 4 here, A will also be 4 there. If B is 3 here, it's also gonna be 3 right there. So let us see if A is 4 and B is 3. 4 plus 3 is 7. So this one is correct. But 4 plus minus 3 is actually 1. So you know what? This one is not correct because we can see that the question is saying, or the equation is saying A minus B is 3. So we know that we can't work with 4 and 3. So let us guess another pair of numbers. Let us try 6 plus 1. Now 6 plus 1 equals 7, but 6 minus 1, it equals 5. So we know that this A cannot be 6 or B cannot be 1. We're going to try another number. We're going to try 5 plus 2. So 5 plus 2 equals 7. We know that is correct. And 5 minus 2 equals 3. So we know that, therefore, A equals 5 and B equals 2. So there you have it. We actually just solved our equation. Now, looking at that in itself, if, like, for example, in an exam condition, would be considered a lengthy approach, and that will consume a lot of time. Thankfully, there are formulas, or there are steps that can be taken to solve these equations without having to be guessing what represents what. So we'll be looking at that. All right. So let's go ahead and delve right into our lesson. Now, in solving simultaneous equations, there are more than one ways we can actually do this. But for this lesson particularly, we'll be looking at the substitution method and the elimination method. Now, how do they work? Now, the substitution method, we're going to work with the same equations for both examples, for both methods, right? So let us first talk about the substitution method. Now, I just want to start by saying, using our substitution method, we can always use the substitution method as well as we can always use the elimination method. But there's just something in particularly about the substitution method that it can be a troublesome method if you're going to use it to work out some of these simultaneous equations. Let me just explain what I'm trying to say. So x right here is 1x plus 3y equals 19. Now what I tell students, I usually tell them that just use the substitution method when you are given one of the variables x or y where the coefficient is 1. So I say choose the variable where the coefficient is 1, because if you were to choose 3y equals if you were to choose to say you're going to substitute the y with the 3 being right here, you're going to end up with something like this: 19 minus x divided by 3. And that, to work with it like that, can be bothersome for most students. So I would normally just say to them, just work with the variable with the with the coefficient of 1. So just work with that variable. So in this case, the variable that we're going to be choosing is our variable x. So what I like to do as well is that where we have x plus 3y equals 19, this is a positive 3y, and we want to get rid of it because we need to just have an equation that solves for x. In doing that, if this is a positive 3y, we can subtract the 3y to remove it. And if we subtract it there, we also have to subtract it here. Right? So these two are just going to be cancelled out. So I'm just going to erase that part so we can see what we're really working at. All right, so looking at this now is that we have x equals 19 minus 3y, right? So in having this, we actually know we can choose any of the equation right here, either 4x minus 3y equals 1, right? So one of the things that I'm going to do is that I'm going to choose this equation right here. And then now you have to pay attention to what I'm about to say very carefully, right? That this x right here, I'm going to have a bracket for it. And in this bracket, I'm going to represent what I just solved for x. So we have something to represent x here. And x equals 19 minus 3y. We're going to put that right here. So what we are saying right here is that this x, we just solve for x. So we just solve for x. And in solving for x, we're going to sub this value of x right here, this value right here, into equation 1. So this is equation 1 and this is equation 2. Equation 1, equation 2. Right? So I take this value of x and I sub it into equation 1 for x. So where I have 19 minus 3y, I just sub it and then I just write out that everything there. So 3 minus 3y equals 1. So that is literally the first step in solving using the simultaneous equation, right? Now, let us continue here. We know that 4 times 19 is going to give me 76, right? 4 times 3 is going to give me, that's going to give me 12y. And we just rewrite 3y equals 1. Simple so far, right? Just for the sake of space, I'm just going to come over here to my left. So I'm just continuing from here to right here. So 76 minus 12y and 3y. Now when we're talking about 12y minus 3y, if we have a negative being subtracted by a negative, the rule is that we can, once we have the same signs as we would know it, once you have the same signs, we add. So when we have negative 12 minus 3, we're going to add 12 and 3. Right? And then we just keep the sign. So 12 plus 3 is 15, and then we keep the sign. Right? Just remember that little rule. All right. So with that being said, we're just going to rewrite what we have right here. So I'm just going to take this workout and put it right here. So now we actually have 76 minus 15y equals 1. So 76 minus 15y equals 1, right? So the next thing now is that we want to solve for y. So this 76 right here, we need to bring it over to the right-hand side of the equation, right? So this 76 right here is going to go over to the other side. So in doing that, we need to subtract it here. And if we subtract it there, we also will have to subtract it here. So these two are going to be cancelled out. Now I'm left with negative 15y equals 1 minus 76 is 75. Now we have, in fact, it's negative 75 for that matter. So this negative 15y here, we need to solve just for the y. In solving just for the y, we're going to divide the negative 15 here. And if we divide it there, we also have to divide it here, right? So negative 15 into negative 15, they are going to be cancelled out. And now I'm left with y equals negative into a negative is just going to give me a positive, and 15 into 25. So 15, 15, 115 is 75. That's just going to give me 5. So y equals 5. So there you have it. So if you realize now that the only thing that we have done here is only to solve for y. So we need now to solve for x. Now I'm actually going to use this to represent for x, because this x right here is already in a solving position, or in a solving mode for x. So x equals 19. So just going to write that now. I'm going to use another marker to represent that. So x equals 19 minus 3. We know what y is, right? So y is 5 right here. So we're just going to put the 5 right there. So then now we actually can work it out. So 19 minus, this is going to be 15. 19 minus 15. So x equals 19 minus 15. Therefore, x now actually equals 19 minus 15 is 4. So there we have it. X equals 4 and y equals 5. So we would have something that says, therefore, just have a therefore sign, and we say that x equals 4 and y equals 5. And there we have it. Right, so that is my answer. Right? So let us now talk about the elimination method, right? Now, in doing the elimination method, we have to bear in mind that when we look at our variables x and x, y and y, we need one of the variables to have a coefficient that are the same. So the pairs of coefficient of one of the variables must be the same. If we look here, we see 4 and we see 1, because you know that just having the x right there means that the coefficient is just 1. So we cannot readily eliminate the x. There is a way we can go ahead and eliminate the x, but in this right now we can't do it. But here we can go ahead and eliminate the y. So where we have 3y, negative 3y plus 3y, we see that we have the same number here and the same number here. So y have the same coefficient, which is 3. Right? Don't mind the signs being negative or positive. We're really focusing on the actual number here. So we could go ahead and eliminate. Now in eliminating something, when we're adding or subtracting, so we add or subtract to eliminate. And if when adding or subtracting, if we can get it to equal to 0, it means that we have gotten rid of it. So we have negative 3, just going to ignore the y, right? But maybe for some persons would like to see the y, I'm just going to use it, right? And we have plus 3y. Now, I have to either add or subtract to eliminate, right? So I have to choose one of them. If I choose subtraction, this is going to be saying negative 3y minus 3y. And as I said before, is that when you have two of the same signs there, you're actually going to add them. So same signs add, and then you keep the sign. So in this now, this would actually give us negative 6y. It doesn't give me 0. So I can't work with that right there, right? So I have to work with something else. So I can't work with the negative. So I'm going to try again and say negative 3y. So we have negative 3y plus 3y. So I work with negative. Now I'm just going to try and work with the positive. So negative 3y plus positive 3y is going to be saying negative 3y plus 3y. And we know that where we have the same two numbers here, this is literally saying 3y minus 3y. And that is going to equal to 0. So we need to add here to eliminate. And if we add there, we also have to add here and there. So that is how we actually eliminate. All right, so in eliminating our y, we are we're actually going to be solving for x, start solving x. So 5x plus x is, 4x plus x is 5x. The y's are now being cancelled out. 1 plus 19 is going to give me 20. All right, so 5x equals 20. Now in solving for x, we're going to remove the 5, we are multiplying 5 and x, so we need to remove it by division. And if we divide it there, we also have to divide it there. So the 5s are now being cancelled out. 5 are being cancelled out. 5 into 20 is 4. So I'm left with x equals 4. So we just solve for x. Now we need to solve y. So we can choose either of the equation, right? So let us say we're going to choose this top one in this case. So just going to use another marker to work that one out. So we have 4. We know what x is. X is 4. So we're just going to plug in we're going to use our 4 in our x value right there. So 4 minus 3y equals 1. 4 times 4 gives us 16. So we have 16 minus 3y equals 1, right? Now, we need to get rid of the 16 because we need to leave the negative 3y on one side. So, in getting rid of this 16, we are now going to be removing it. So we remove it because it's a positive 16, in remove it, we have to subtract it, right? In subtracting it, if I subtract it here, I also have to subtract it there. So the 16s are being cancelled out. And now all I'm left with here is negative 3y equals 1 minus 16 is going to give me negative 15. Right? So that's going to give me negative 15. So negative 15 is right there, and we have negative 3. Just for the sake of space, let me see. I'm just going to utilize somewhere on the board. Maybe I can just remove the question for now. I'm just going to remove the questions for now. So I'm just going to work with at the top right there. So negative 3y equals negative 15. Just let us write that back out so we can see what we're working out. So we want to solve for the y. So we are going to divide the negative 3y here by 3. And we're going to also divide it here. If we divide on one side, we have to divide it on the other side. So the 3's are going to be cancelled out. And note that I'm taking out the entire negative 3. Right? So I'm left with y equals negative 3 into negative 15 is just 5. So there I have it, 5. So now I have, therefore, we can say that therefore x equals 4 and y equals 5. I mean, simultaneous equation is really a lengthy topic, but I mean, I'm sure you get the gist of it and so forth. But let us look at how that really works. So we know we solve for x and we solve for y using both equations. Now, I want to look at something very interesting when working with that. Okay, so let us talk about 4x minus 3y. We said that, what did we say about x? We said that x is 4. What did we say about y? We said that y is 5. Let us see if 4 times 4 minus 3 times 5 equals 1. Let us see if that is true. So 4 times 4 is 16, and 3 times 5 is 15. 16 minus 15 equals 1. So we know that x is indeed 4 and y is also 5. Let us go to the other one. So we're just going to use the other equation now to see if it works. So we know that x is 4, and we know that 4 plus 3 times 5, which is 15. We say that that is 19, right? So let us see now if this is correct. 4 plus 3 times 5 is 15, and 4 plus 15 really equals 9. So there we have it. So we can see then that that x definitely equals 4, and we can see that y indeed equals 5. So that is how you use the substitution method and the elimination method. Now, in wrapping up this lesson, I want to talk about our elimination method a bit further. Now, in our elimination method, there are three possible scenarios that we can use to begin our elimination process. So I'm going to start with this equation at the end. So here, if you look carefully, is that we have 2x right here, we have 5x. If you really listen to the previous example, I mentioned that you cannot go ahead and eliminate if these two numbers of or two coefficients of x are different. The same is true for the y. So we can't readily eliminate. So I just want to look at what possible choices do I have to let these two coefficients actually have the same value, right? Either any one of them can have the same value. Either the x have the same value or the y's have the same value. Whichever one that you're going to choose to eliminate, either you're going to eliminate the x or you're going to eliminate the y. If you're going to eliminate the x, then you can actually work out how to get these two values to be the same. And if you're going to eliminate the y, you can work out how to get these two values to be the same. Now, how to get these two values to be the same is that we can either multiply one of the equations or both of the equations, or we could also divide one of the equations, right, to achieve that goal. So let us label this equation as equation 1 and this equation as equation 2. So if you look carefully, if we were to look here, we can see here that where we have the 6y here, right? We can let the 6 be 3 if we were to divide the 6. But in doing that, I have to make sure that these variables, these coefficients 2 and 14, are also divisible by 2, right? For best practices, at least, right? So we can see that this entire equation here can be divided by 2, right? So if it can be divided by 2, it means that I could simply just divide it. So if in dividing it by 2, so I'm going to take equation 1. So this is equation 1 right here. I'm going to divide it by 2, right? In dividing equation 1 by 2, I'm going to get 2 into 2 is going to give me 1. So that's 1x, or just x, right? And 2 into 6 is going to give me, remember the plus sign, is going to give me 3y. And then we have 14. 2 into 14, that's going to give me 7. So this now would be equation 3, which is an equivalent equation of that of equation 1. So let us look at that. So we could simply now have that, and then now just, this could be up here or down here, it doesn't matter. So we have 5x minus 3y equals 5. So this now is sufficient now to go ahead and eliminate. So you can now go ahead and eliminate. Remember, when you have different signs, you can add to eliminate. So you can even just go ahead and work this out to see what you get, right? And you could also use other methods that I'm going to show you in elimination to see if you will get the same answer throughout. So we're going to just mix things up. So here we are now going to take equation 3. So equation 3, we're going to add equation 3 and equation with equation 2. So we're just adding the two equations. Okay, so just have that in your mind. So you can just go ahead and try that one. So that's one possible method. Now the next way of starting my elimination process is that, so in this case, we divided one of the equations by 2. In that case, we divided equation 1. Here, in this one now, if we look carefully, these are 1. So we can choose to multiply the equation 1 and equation 2. We could choose to multiply the first equation by 3 or 2 in order to get the x to be 3 or to get the y to be 2. So we have the option of multiplying equation 1 times 3, or we could choose to multiply it by 2, whichever one is fine. So we're going to multiply it by 3. So in doing that, we get 3. So multiplying this by 3, we're going to get 3x plus 3y equals 9. And then we could just write back the equation that's at the bottom. If you realize I'm not multiplying or doing anything to this equation. So if you look carefully now, we actually have both coefficients having the same value, right? And if we look here now, even though this is a 3 and this is a 2, the fact that we have one of the variables having the same coefficient, that is also fine. So that will satisfy our requirement in terms of elimination. So we could have gone ahead now and eliminate. So these are positive. Remember now that when you have the same signs and you want to eliminate, you subtract. And if you subtract there, you have to subtract there. So you have to subtract throughout. So these two would have been cancelled out. And this now would give me y equals 9 minus 7 is 2. So you could go ahead now and actually plug in that 2 right there into your y and solve any of the equations, right? So you can go ahead and try and work that one and see what you get, right? So looking at this now, we have 7x minus 4y equals 37. And we have 6x plus 3y equals 51. Now, if you look here now, in this scenario, there's nothing that we can multiply 7 with to give me 6, right? And there's nothing that we can multiply 4 with to give me 3. And it's the same is true when dividing. We can't divide any of them to give me, to get the x to be the same or the y's to be the same. So there's another way how to do it. This is the third and final scenario where we can literally cross multiply. Or in essence, we take equation 1 and multiply it by equation 2 and I should say. So we take equation 1 and multiply by equation 2, and we also take equation 2 and multiply it by equation 1. So there we have it. So if I'm going to eliminate the x, I'm going to take the coefficient of x and the coefficient of x at the top and the coefficient at the bottom. I'm going to cross multiply. So this 6 right here is going to multiply this 7 right here, and it's going to multiply everything that's in the bracket, right? The same is true for this 7. 7 is going to multiply everything in this equation. That's what I'm saying. So we literally have like a cross multiplication right there. So this is going to multiply this entire equation. And you could have done the same thing for the y. You could have multiplied this by the 4, and the 3, now this would have been multiplied by the 3. Whichever one you want to eliminate. If you want to eliminate the x or the y, you can do any one of them, right? So since we start out with x, we're just going to write that out. So 6 times 7, that's going to be 42x, right? Minus 6 4 is 24. 24y that is, and 6 times 37, that's going to give me what? 220, 22, I believe. Let me just double check. And just 6 7, that's 42. 6 3 is 18, so that is correct, right? Here now we have 7 times 6, that's 42x, plus 7 3 is 21y. I just want to ensure that. And 7 times 51, what's that going to give me? 357. So you could actually take the long shot of doing that, right? So now we have 42 and 42. So we could have gone ahead and just go ahead and eliminate. The signs are the same. Remember, when you have the same signs, you subtract to eliminate. So you would subtract right throughout, okay? So what you could do is just go ahead and pause the video, and you can try and work out the values for x and y in all 3 situations. I'm going to put them on the board so you can actually look at it and see if your answer is correct. Okay, so there we have it. We have for our first solution, x equals 7 and y equals 3. Our next solution, x equals 1 and y equals 2. And for our last solution, we have therefore x equals 2 and y equals 5 over 3. All right, so thank you very much for tuning into this lesson. I hope this was a powerful session. I hope that you have truly gotten much. Okay, so please remember to like, share, and subscribe to my channel. Also remember to check out my other YouTube videos on algebra, where you can actually use different solutions in solving other equations. Also, I have my short videos. You can check those out as well. And there are lots of mathematical solutions, ideas that are there. Until again, thank you and take care.